Okay, ladies and gentlemen. So we are going to be um, going over this lesson. This lesson is going to be a little different than the other lessons in that I'm not doing a PowerPoint this time. I'm just going to do some sample problems. And it's mostly about how to do these problems. Basically, what we're going to do is we're going to do what's called, let me go ahead and write this down, dimensional. Let's see, if I write slowly, it works out, but it takes forever. Dimensional analysis. And dimensional analysis is the process of using your units to figure out how to do unit conversions or convert your units. So I am going to kind of give you some of the background, some of the theory behind it here, or some of the math, basically. It's not as much theory as it is math. So I'll tell you how this works, then we'll do some sample problems. Okay. The basic idea here is this. Let's say you have some quantity. Let's say you have, you know, let's say you have um, A feet. And by A, the A here is just a number. And, well, let me go back. So let's say that we have some quantity, some value, here, some A, right? So you have this number A, and A is going to go ahead and you're going to want to convert it into a different form. You don't want to change its value. Okay? A has some value. A could be 8, it could be 1,000, it could be whatever. The whole idea here is this. It has a value. We want to convert it to another form, just like we can convert two two measurements into different forms. 2 feet and 24 inches are the same thing, right? They're the same measurement, but they're in different units. So 2 feet and 24 inches are the same thing. If you didn't know, 1 foot is equal to 12 inches. So 2 feet would be 2 times 12 or 24 inches. Right? So let's say you knew that that the values x and y were the same. X equals y. We can use this equality, this is an equality, in order to create what's called a conversion factor. And, well, we can use this as an equality. Since there's an equality, if we take one side of the equality and divide it by the other side, you end up with the value of 1, x divided by y. Since x and y are the same, and an example could be, let's say this number is 2, and this y is 4 halves. They're both the same value, they just kind of look differently, right? And that's kind of like, 2 feet or 24 inches. They've got the same value, they just look differently. So if x and y are the same, if I take x divided by y, since they're the same, any number divided by itself is going to be equal to 1. And therefore, whenever you multiply any number by 1, you get the same number back. So x over y can be multiplied to any number because it's equal to 1. And when you multiply it to that number, it'll give you the same number back. So let's say I take the x over y and I multiply it by a. So take a, multiply by x over y. Since x over y is equal to 1, it's like a times 1, so we're not changing the value of it. But now I'm going to end up with a times x in the numerator, and y stays in the denominator, right? Because whenever we have a number over here, it's a whole number, it doesn't have a denominator, we assume that the denominator is 1. So 1 times y is y. All right, we just ignore it. So there's a whole number, or a number that's not a fraction, it goes with the numerator in a fraction. We multiplies the numerator in a fraction, just to remind you. Okay. So this expression here, a times x over y, is the same thing as a. It just looks differently, but it's the same thing. And since x over y is equal to 1, and the reciprocal of 1 is 1, then we can also say that not only is x over y equal to 1, but y over x is also equal to 1. I know this sounds like a lot of math, but this is the math behind it. Because this is what we're going to be doing with our units, basically. And we're going to allow our units to help us try to figure out whether we should multiply or divide things. So instead of, let's say, taking this value a that we started off with, Instead of multiplying it by x over y, we multiply it by y over x. We're going to get a times y, right? Multiply these two in the numerator, divided by x. That also equals to a. So these two expressions are actually equivalent. It just turns out that sometimes this expression might be more useful than this one, or vice versa. It really depends on the units. And I'll show you what I mean in just a little bit. But that's basically what we're going to be doing in our sample problems, and we're going to go over them slowly. This is the math behind it. And really what you're doing is going from, let me go ahead and change the color on this. Let's go with green. You're going with an expression or a value or a quantity expressed in one way, and then finding a different way to express it. Just like saying that 1 foot equals to, oh, I should say, what do we say, 2 feet equals to 24 inches. Okay. These two things are the same thing, they're just being expressed differently. This looks a little more complicated because the A's and Y's, and I'll show you why. I'll show you why I needed to use this format right here. We're going to have what's called a conversion factor, and you won't really understand what a conversion factor is until you actually do a sample problem. So let's go ahead and do some sample problems. And from here on out, all we're going to be doing is sample problems. Okay. So let's get going on that one. Actually, let me go ahead, get the black back. Oh, you know what? I'm going to pan this a little bit. Let's do a sample problem. Get out your calculators because we're going to be doing some calculations. All right. So let's say you have 72 inches. I need to put my pen on here first. 72 inches. The question is, how many feet is 72 inches? So I want to convert my 72 inches into feet. Now, in order for me to do that, I needed to know the relationship between feet and inches, right? And as I said earlier, 1 foot equals to 12 inches. So in essence, what we're doing here is proportions. And if you can do this in a proportion, you know, write it out as, see how we're going to write this. We want feet to be in the numerator. So 1 foot over 12 inches equals to x over 72 inches. Because the 1 foot over 12 inches you're given here, and the 72 inches is what you're given right there, and what you're looking for is this. If you can do it this way, that's fine. This is not the way I'm going to teach you right now, but it is proportions, and you've learned proportions in the math class. So I just solve for x at this point in time. The way we're going to do it, because sometimes proportions get a little cumbersome, especially when it's multi-steps, when you have to do several steps. So let's do this. What you're going to do is you're going to go ahead and take your given number. Here's 72 inches, so I'm going to write down 72 inches. And the 72 inches then is going to be multiplied by what we call a conversion factor. And I'm going to go ahead and do it this way. I'm going to make a little kind of cross thing here. And what this is supposed to represent, and I could have also done it this way, 72 inches multiplied by, in parentheses, it's going to be a fraction. So this here right here, it represents a fraction. And the fraction is going to be your conversion factor. So as I said earlier, write this down, conversion factor. The conversion factor is going to come from your equality. So you're given 72 inches. You don't know how many feet. So you write down your given right here. Then this next spot over here is going to be where you put your conversion factor. And all the conversion factor is taking one side of your equality, right? Because this shows the relationship between feet and inches. You take one side of your equality divided by the other side of your equality. And since they're equal to each other, this conversion factor is always equal to 1. So conversion factor is always equal to 1. That's how you make a conversion factor. The question is, which side of this conversion factor, or this side of the equality, goes on top and goes on the bottom? Okay, so one side's going to go on top, the other side's going to go on the bottom. So which is which? And here's where the dimensional analysis comes in. The dimensionals that they're talking about in dimensional analysis has to do with the units. Here we have inches. So the inches here is going to tell you kind of how to do this. You're given inches, you want to end up with feet. Right? You're given inches, you want to end up with feet. Which means that you want to make a situation where the inches cancel out. You don't want to have inches at the end. So what I'm going to do is I'm going to take this side, the right side, that has 12 inches in it, 12 inches, and put it down here. And the reason we're going to do this is because, as you're going to see, now we're going to end up with inches on top in the numerator and inches on the bottom in the denominator, and those will eventually cancel out, and I'll show you how. I'll show you right now. So if one side of the equality goes on the bottom, the other side of the equality goes on top. 1 foot. And notice that the number in the equality, each unit has a number that goes with it. The number goes with the units. So the 12 goes with the inches on the bottom, and the 1 goes with the feet on top. That's going to tell us that we're going to need to multiply by 1 and divide by 12. So let's go ahead and do that. So what you have here is 72 inches. Then you're going to multiply by 1 foot and divide by 12 inches. Let's do this first with the numbers, because the numbers are easy. We're used to doing the numbers. 72 times 1 is 72. 72 divided by 12, I put in the calculator, it's going to give me 6. So the answer is going to be 6. 6 what? Well, I'm going to end up with, remember I said in the last video that inches and, that units are treated like variables. So treat your units like variables. So if I have inches here and I have feet here, they don't cancel with each other, so I just go ahead and multiply them together. It's like x times y gives you xy, right? So inches times feet. Inches times feet gives me inches times feet. The 6 was already taken care of. The 6 came from the numbers, multiplying and dividing them. 72 times 1, multiply the two numbers that are in the top above this line right here, the numerator. These two numbers are in the numerator. And then divide by the number here that's in the denominator. That gives me 6. So that's the resultant from there. Now the units here, inches and feet, are both in the numerator. I'll put inches and feet here. And then I can go ahead and the only units that are left in the denominator are also inches. There's nothing else to multiply it by. So my units end up being inches here and inches and feet. At this point, this is where a lot of people just get the numbers and they just kind of take a guess at the units. Don't do that. You can use the units. Units are very useful in order to figure out, what your answer should be and what units they should be in. And they tell you whether you should be multiplying or dividing. Should I have multiplied by 12 or divided by 12? Should I put the 12 on top or keep the 12 on the bottom? The fact that the inches are on the bottom tells you to put it on the bottom. And here's why. Because now that we've got to this point, you'll notice that there's inches on top and inches on bottom, so they cancel. Right? A number divided by itself, or a variable divided by itself, equals 1. So they cancel out, leaving me with a final answer of 6 feet. Now, that took a lot longer than it normally would. That's only because I was kind of showing you how to do this. So in the future, it should be much quicker. But for right now, it took a little while just because I was showing you kind of how that happened. Really, normally you can just go, okay, there's inches here on top, here on the bottom. Eventually they're going to cancel. So you can just cancel them out right here. Don't have to bring them over here. And what you'll be left with is just feet. Okay. Now, one last thing before I go on to the next sample problem. And all the sample problems are going to be like this. You write, let me go ahead and change colors again. Let me do blue. You write your given right here. You make your conversion factor here based on the equality that relates the units that you're given to the units that you want. So you need to know the relationship between those two units. So here's your given number, and then you make a conversion factor from the equality that relates the units in that given quantity to the units that you're going to eventually want. You make the conversion factor by using that equality so that one side of that equality goes on top, the other side of the equality goes on the bottom of the conversion factor here. And the key is to get the units to cancel. So you're going to use the units that were given here in your given, you're going to use those to decide that this side here goes on the bottom. Sometimes one side will go on the bottom, sometimes the other side will go on the bottom, depends on what you've got. Now, what happens if you mess up? What happens if you do the conversion factor that's upside down? You'll be able to see it in the units at the end. Let's say instead of, let's say we have 72 inches, and I wrote this down here already, so let me go ahead. I'll do it over here. No, I have it like that. I'll erase this here. Let me go ahead and make this a little nicer. Redraw. Okay. So here's where I'm going to put my conversion factor. Let's say instead of putting 1 foot over 12 inches, I put 12 inches over 1 foot. So now I'm going to go ahead and say, oh, now I have to take 72, and since 72 is in the numerator, and so is 12, I need to multiply them together. So 72 times 12 is going to give me 864. Hey, maybe the answer is not 6, but it's 864. Maybe I should have multiplied instead of divided. How do I know that this one's wrong? Well, check out what happens with the inches. I have inches in the numerator here. I also have inches in the numerator here. They're both in the numerator, so they don't cancel. Actually, if you had x here and x here, you'd end up with x squared, right? So now we don't have x's, we have inches. But since inches are multiplied by inches, we end up with inches squared in the units. And then there's the only unit that is in the denominator is feet, so you're going to leave it feet. So you're going to end up with units of 864 inches squared per foot. What does that mean? That's not what we wanted. We wanted to convert our units from inches to feet, and that's it. We want to get rid of inches. So by using the wrong conversion factor here, by using this reciprocal of this one, right? This is the reciprocal of this one. We used the wrong one, and we got some nonsense units, so we're not going to use that. That's not the answer. We are sure that this is the answer because in this case, our units canceled. When we set up the conversion factor like this right here, our units canceled, leaving us with the units we want, and so therefore, this is the answer to our question. One more time. This one went longer because I'm showing you kind of the whole idea. The next problem should be much quicker. Okay, so let's go ahead and do a second problem here. Let's say that you have 29,000 feet, planes flying at 29,000 feet above the ground. And what you want to do is know, well, how many miles is that? 29,000 feet sounds pretty high. How many miles is that? So let's convert it into miles. Okay. We got to know the relationship between feet and miles. So the important thing here is, well, we got feet, we want to turn them to miles. What's the relationship? The relationship is that 1.0 miles equals to 5,280 feet. So you're not going to have to know this. You will be given this. All I want you to do is be able to go ahead and do the conversion. So you don't have to know it. You'll be given these. You'll be given any conversion that has an English unit related to it. The metric units, as we're going to see later on, I'm going to expect you to be able to know the relationship between the metric units. So here's how we do it. This is our given. We're going to take our given, 29,000 feet, and we're going to go ahead and we're going to convert them into miles. So let's go ahead and make a little X there so we can write our conversion factor over here. Right, the left side of our equality has 1.0 miles. The right side of our equality has 5,280 feet. So which one goes on the top, which one goes on the bottom? You'll notice that our units given are feet, so we want feet to be in the denominator over here. It doesn't matter what the unit would be, we want the feet to be in here. So therefore, we're going to take the feet along with the numbers that go with it, the 5,280, 5,280. Okay. And see, by looking at the feet here, putting the feet here, it tells you whether you're going to multiply or divide by this number. Is the 5,280 going to go up here or down there? Well, because we started with feet, we want feet to cancel out. We're going to put the feet on the bottom here. So the side with the feet brings its numbers, brings its number down on the bottom. You can see already, even before I put the other side in, you can see that feet are going to cancel. And I don't have to do it at that point, but just to show you that This doesn't happen by coincidence also. This is actually, what is happening. You set that up so that it cancels out. The other side of the equality now goes on top, 1.0 miles. And now these are the only units that are left, so that's what you're going to end up with. I don't even have to do the calculations first already to know that now my answer is going to be in miles. The question is how many miles? Well, that's where the numbers come into play. Okay. We're going to take the 29,000 multiplied by 1 divided by 5280. So let's go ahead and do that in our calculator. So 29,000 multiplied by 1 is 29,000. Then you divide by 5,280. Every mile is 5,280 feet. And you get 5.49, almost 5.5. About 5.5, 5.49. If we were to round it to one decimal place, then it would be 5.5. But here I got 5.49. Actually, I got 5.492. We'll go over rounding. As far as rounding is concerned, a lot of people get to worry, well, where should I round it to? Round it to 2 or 3 decimal places for this one. There's actually rules that go with rounding, but we haven't got there yet. That'll be next week's lesson. So for right now, round wherever you can. Here's your answer. Okay, so that's the second one. Let's do another one. Let's go ahead. We keep using meters and feet and length, but you can use this with any units. We're going to, let's see, go ahead and put a pen in here. Let's do this. Somebody weighs 180 pounds. Well, how many kilograms is that? Because, in other countries, they tell you how many kilos they weigh, not how many pounds. So let's say you have to convert it to let somebody, in Mexico or in Canada or in England, how much do you weigh, they ask. Well, 180 pounds. I'm sure not everybody here weighs 180 pounds, but whoever this person is, they weigh 180 pounds. How many kilograms is it? Well, you got to know the relationship between pounds and kilograms, and I will give it to you. And that relationship is 1.0 kilograms equals to 2.2 pounds. And seeing this, basically from here, you can already see. I'm going to have to either multiply by 2.2 or divide by 2.2. The question is, which do I do? Multiply or divide? Well, let's set up our dimensional analysis. Got 180 pounds. I go ahead and make my little thing here. By the way, college students love doing this. So if you think this is kind of, wimpy or high school, college students, because later on we'll see when we have multiple calculations, they can just continue it on. So 180 pounds right here. So we want pounds to be down in the bottom here, so it can cancel, right? And so therefore we can go ahead and see that pounds is on the right side, and in the equality there are 2.2 pounds. So we put the 2.2 here, which tells me right now that I'm going to be dividing by 2.2. So if one side, the right side goes on the bottom in the denominator, the opposite side goes into the numerator, 1.0 kilograms. And now we know that our pounds are going to cancel. What we're going to get is 180 times 1 divided by 2.2, right? We've got, where to use my calculator, 180 here. I multiply it by 1, and I divide by 2.2 in case. Remember, guys, I don't know why high schoolers at this point have a hard time remembering this. Everything in the numerator gets multiplied. Everything in the denominator gets divided. So we're going to do that. We're going to take 100 times 1 is 100. And, I'm sorry, 180 times 1 is 180. Divided by 2.2 is going to give us 81.8. 81.8. So write that here. 81.8. And our units now are kilograms. All right, so if you weigh 180 pounds, you can tell somebody you weigh 81.8 kilograms, or at least that's your mass, because remember, kilograms is mass. We're not going to, mess with it. Just going to make sure that, kilograms technically is mass and not weight, but people use mass and weight almost interchangeably. Just know, technically, in a physics class, you're going to have to differentiate between the two. All right, let's do one more. Okay, for the last one on this video, let's go ahead and try to turn 42 centimeters into meters. Let me go ahead and get a pen here. 42 centimeters. How many meters is that? That's an ugly question mark. These are question marks in case you haven't noticed. All right, so 42 centimeters, how do we turn them into meters? Well, once again, we need to know the relationship between centimeters and meters. Now, this one, I'm going to go ahead and expect you to know the relationship. Okay. I'm not going to give you this one. You'll have to come up with the equality on your own. But you should be able to do it because we learned about the metric system the other day. And so this is a meter over here, and this is a centimeter. So centi, you should know that centi means 1/100th, right? So either you can write it like this way: 1 centimeter equals to 1/100th of a meter, or 0.01 meters. That'll work. Or what you can do is you can then go ahead and go, all right, let's get rid of the decimals by multiplying both sides by 100. And when you multiply both sides by 100, you get 100 times 1 is 100. 100 centimeters is equal to, well, the reason I multiply by 100 because this is 1/100th, right? 1/100th times 100 is going to give you 1 meter. So 1 meter is 100 centimeters, and that's what I put as an example on our video earlier. So this relationship you should be able to come up with on your own. Once you have that relationship, now you write down, okay, 42 centimeters. Then you can go ahead and create your conversion factor format right there. We want centimeters to cancel, so this time centimeters is on the left. We're going to put that on the bottom. 100 centimeters goes on the bottom. That way they cancel. Once again, centimeters here on top, so therefore we want centimeters down at the bottom so that they cancel. That doesn't just happen on its own. It doesn't happen by coincidence. You made that happen. The other side has 1 meter on top, so I put the 1 meter here on top. And what I'm going to get is 42 times 1 is 42. Divided by 100, even if you plug into your calculator, you'll get 0.42. And the units left are meters. Okay. And that's how you do that. Okay. Now you'll notice that I came up with, this one was nicer and easier to use. This 100 centimeters equals to 1 meter because there's no messy decimals. But even if you did use this other one right here, you're like, oh, I remember that centimeter is 1/100th of a meter. Even if you just wrote it as 1/100th, it should still work. Right, so let me go ahead and show you real quick how that happens. 42 centimeters, then you go ahead and put it in as a conversion factor. If you're going to use this equality here to make your conversion factor, you can. Still, the centimeters goes on the bottom. You're going to end up with 1 centimeter on the bottom over here because of this right here. And you're going to end up with on top 0.01 meters. 0.01 meters. And if you use that in place of the 1 meter over 100 centimeters, you're going to get the same answer because 42 times 0.01 is 0.42 divided by 1 leaves you with 0.42. So regardless, you might go, oh, well, you know, what if I can get this, but I can't turn it into this? You'll still get the same answer. Right? Both of these are the same. Both of these are equal to each other. You know, basically the denominator here is 100 times bigger than the numerator, so that's why you get the same answer. Okay, so hope that was helpful.